All right, so the last principle is called Dependency Inversion principle. Now this one kind of try to explain how we're going to implement that open close principle. How do we ensure that it's open for extension but closed for modification? And again, I really like this image right here. It shows this idea. So as you think about, if you're trying to build this power outlet, the really cool thing about this one is you can plug in any kind of electrical devices to here. It really doesn't matter if it's a light or a computer or a charger or whatever, as long as your cable fits with this kind of interface. And also behind the wall, right? So you got the wire from the from the station and all the way to your house and eventually to the power outlet, right? And the cool thing is that all the electricity devices, they don't need to know anything about how you transfer the energy to right here. And also the cables, the wire behind the wall also doesn't need to care about what kind of electricity are sending here, because both sides are depending on this interface. That's how the things can be worked so smoothly and flexibly. So that's what this principle is trying to tell us. All right, so the definition is like this. And the high-level modules should not depend on the low-level modules implementations, and both levels should depend on abstractions. And abstractions should not depend on details. Details should depend on abstractions. So basically, we're really talking about this whole abstraction. And abstraction in Java, basically, that is the interface or abstract class. Now remember, I mentioned about this car example in the first principle. You're changing the car engine from piston engine to a turbo engine. Then you better have some kind of a container there that you can put any kind of engine easily, just like the car dashboard, right? So go back to take a look at that example. So that's why the open close principle states the goal of the design, and then dependency inversion principle states the maximum. And to be more specifically, okay, so we should always try to apply this strategy of depending upon interface or abstract functions and classes rather than upon concrete functions or classes. And no dependency should target a concrete class. All right, so let's take a look at a specific example. Let's say if you want to build a function to copy things, copy some data from one place to another, from a source to target. And a really good design would be something like this. And then you are using some kind of a source input, we call it reader, and then you're trying to write it somewhere else in target maximum. So you have a writer class. And then both reader and writer are interfaces. They didn't implement anything, but they provide an interface such as read the data and write the data. And now we can build our concrete class. So for example, the reader, we can send the data from a keyboard, and then keyboard will just implement the interface to implement how do we get the data from a keyboard. And we also have a writer that prints data to the printer and just follow this interface to implement that one. So this will make our copy methods so flexible, because now you got a reader class and writer class, and then the copy method just depends on reader and writer. It doesn't really care about what kind of reader and what kind of writer it is. So if you do it this way, and if you have a keyboard reader, you can easily copy things from keyboard to printer. Or later on, you got another different type of writer, such as the disk, and you can write the same thing to a disk without changing any part of this code. As you can see, as you do this kind of changes, you're only adding things, making extensions, but you're not modifying the existing code. All right, so this is what the dependency inversion principle tells us. Always use a interface, and always depend on the interface, and you will always benefit from it. And here's another good example in practice. If you're familiar with the Java I/O libraries, you got an input stream, you got an output stream, and then but then you have so many different type of input and output streams. You can read the data from file. You can get things from some of the byte array. That's also very common. You can get things from object directly, and you can also the same way, or write it as object and write it into a byte array. You can write it to some kind of files, and there you can even extend it. You can add some new maximum to network, to some of the socket, anything you want to do. All right, so here's the bottom line. So this principle really tells us that you should always program to interface and not to implementation. always build interface first and try to rely on everything on the interface and use the dependencies with the interface. Don't directly use a concrete class. It is not a good practice. All right, so this principle is really simple. I hope everyone can remember this one and try to always stick with interfaces. And that's how you can make your program more professional, and also you will benefit from the future changes.